Live Streaming is on.
Mhm.
Ja. Okay, super. Ja. Dann starten wir mal los. Okay. Today we'll be talking about how to organize large-scale Rust projects. First, a motivating anecdote. I started with programming Rust about 2.5 years ago, and the first thing we looked into together with Didi, who is always also in this meetup. We wanted to look into Open Ethereum, in the Open Ethereum code base, which is written in Rust, which is one of the largest Rust projects and very prominent in the blockchain, in the Ethereum space. And we started with it and started compiling stuff and changing things. And then we found out that it's pretty tedious to work with that code base. To the point where you have to wait minutes until you can actually see the result. So it's compiling and linking takes forever. And at that point, Didi told me that, David, you can do that on your own. I'm not interested on my laptop. It's too slow. So I started to restructuring the project a bit so I can work on things I wanted to work and put it in separate crates and stuff like that. But I was a beginner. I was just starting out with Rust, so I wasn't sure if that just do it wrong or if the project is wrong or something like that. And yeah, it was then the Rust Fest 2018 in Paris was around the corner. So Didi and me, we jumped a plane and went to Paris and met with the programmers of Open Ethereum, or Parity, how it was called at that time. And we went out with them. They're really nice guys, and I hope we'll get a lot of good tips about how to work with efficiently with the code base. And what I got is a lot of they apologized for the mess they made with some of the core libraries there, and that they themselves are not compiling the project anymore on their local machines. So they just used a cargo check to check if it compiles without errors, and then send it off to continuous integration, and it ran the unit tests and all that stuff, and reported back if there were any problems. Now that's certainly not the way to organize a large-scale project. And looking at the code, it was clear how it happened, but it's really a slowly creeping slowdown. I mean, initially it's fast, but after a couple of years of adding code to a larger and larger crates, then it just gets slower and slower, and at a certain point you have a mess that you have to fix with great effort. So we have got a good case after case, because they eventually fixed it. They eventually fixed the problems. So in the current version 3.1, it's compiling a lot faster, like 3 to 4 times faster, and it's becoming quite comfortable to work with. So we'll see what you can do to organize a project so this doesn't happen. So we'll talk about which techniques are available. Then we'll talk through a couple of case studies. Look at before, after in the Open Ethereum code base. Then we discuss tools, and then we can do a general discussion. As you see, we only have got 12 slides. So if we spend like 10 minutes per slide, that's not a problem. So whenever you want to interrupt, please do, and we can discuss things that we present here.
Can you switch to slide mode?
Slide mode, yeah, slide mode, yeah, but I can't switch between the screens anymore. But yeah, I can do this because I want to switch to code back and forth pretty often in this talk.
All right.
But for a start, we can leave it like that. So what is available? How can we structure a project, a large-scale project in Rust? One way, of course, at the top level, we can use workspaces, which is a special kind of cargo toml file, which is used to organize multiple cargo projects multiple crates into one big project, then of course you can use crates. You can decide which granularity of crates you want, how much you put in crates, how many crates you have, and stuff like that. And then below crates, you can organize the code in modules. And then within the modules, you can, of course, the names that you give to things also matter for the readability and long-term maintainability. So let's recap how a crate is actually organized. A crate is in principle a folder which has got a file called cargo.toml, which describes the project, describes its name, for example, and which dependencies it has, stuff like that. And usually, that can be overwritten, but usually in a folder called src, there's a source. And usually that also everything can be overwritten, but usually in an executable, the source file which would be there is called main.is. In library, it's a source file called lib.is. And if you want to then use modules within the cargo toml file, you can have sub folders with the name of the module, and usually mod.rs would be the entry point for a module. There are other ways to do it, but that's probably the more organized way to build up a crate with modules.
How can you overwrite source? Is it in the cargo.toml file?
Yeah, you can overwrite it in the cargo.toml file. I can show you a quick example. So let's see. So here we got cargo.toml, and here, for example, it says you can say for binary, you can say path equals parity main is, and then it will use that as the entry point.
Okay, not source main rs, but parity / main rs.
Yeah, and when you look at the parity folder, you see that the parity folder itself doesn't have a cargo file. Yeah. So, and so in principle, this parity folder could be renamed to src, and then you can delete that that's path setting, and then it would work just the same. So that's basically an alternative source folder.
Okay.
So then workspaces, I think, is something that we didn't discuss so far in the meetups. As I said, it's a collection of crates sharing, and that's the most important thing. They share the same output and target directory, which means you can then work in those crates, compiling those crates, and they will compile into the base folder, in the workspace folder target directory. And that's pretty helpful because that spares you. That means when you then compile the whole package after working in a specific package, you don't have to recompile because it's all in the same target folder. And of course, it also, one of the most important side effects of a workspace is that all the crates which are organized under it are using a single cargo.log file, which means they use the same versions of their dependencies, which is also, of course, important if you do a large-scale project.
But that also means that if you use one crate in 2 workspaces, it's compiled each time, right?
Yeah, I mean, I've never seen the same crate be used in 2 workspaces, except as a dependency, of course. But yeah, I mean, I don't know if that would even work, because I mean, if you go into a one of these crates which are managed under a workspace, then it must search down the directory tree if there is a workspace. And if there are 2, it will not find the second one. I mean, it wouldn't know where the output if there are 2 of them. I mean, it would probably just choose the first one it finds. In that case.
the workspace is defined in the cargo.toml file, right?
Exactly, in the parent cargo.toml file. So I can show it quickly as well. So probably it's easier to see that. Now here we got a workspace project. I mean, this is a bit more complicated because it's sort of a hybrid. But if you had a pure workspace cargo.toml file, you would just have this section. You would have a section which where the members are declared, and when you then in that folder build or say cargo test or something like that, it will compile all of those and run all of those in one go. But you can go into each single one of these. You could go into ChangeSpec, for example, or AVM bin, and compile there, and it would still produce the build output in the base folder.
Sorry, where in the folder tree is accounts or ChangeSpec? Where is that?
That's relative to the cargo.toml file.
Okay. It's not visible on the left-hand side right now, right?
Oh yeah, yeah. Here it is. For example,
okay,
accounts,
thanks.
FT.
Okay.
Here would be CLI. So here, and these have their own cargo.toml file and their own definitions and stuff like that. And the task of the workspace of Cargo actually is to figure out a way that the dependencies, here's a one cargo.log file which is shared by all of them. So it has to figure out how to use the same versions of the packages there. And that's also, of course, a source of errors when you try to use a different version of a dependency and then try to build everything again, then you will get an error message because it has to figure out a way to get to use the same versions of the dependencies. And yeah, as in this case, it's a mixed. This cargo.toml uses workspace just to also compile command line projects which are not directly linked into the Open Ethereum executable. That's a very idiosyncratic way to use it. So you could also organize the main project like that. And as I said, this is sort of like a hybrid. So it has got the elements of a typical cargo.toml file of a typical crate. Yeah. So it also defines a crate. It defines both a crate and a workspace at the same time. So that's possible as well to do. So at the beginning, it's what you would expect from a regular crate with the name, the version, the dependencies, all that stuff. And oops, hello, test.
I'm here.
Okay, that's my headset made a sound as if it had dropped. Okay, great. Yeah, I've got. Are there any more questions about workspaces?
Well, in theory, you could try to create two workspaces and then go one directory upwards and then down into the directories of the other workspace. And this way we could create the scenario I was talking about, but probably in these members, ... is not allowed. So going up one directory.
It would probably not. As I said, one of the properties is that when you work in, for example, in this folder, in the CLI folder, yeah, and you build and you test and all that kind of stuff, it will still produce all the output in the workspace folder and this one in the target folder, right, in the base folder, which means it has to find it somehow.
Yeah.
So it has to find it. And since there's no back reference from the cargo.toml in the child cargo in the child crate, it has to walk down the path, right?
But but you only need the one direction, right? From the
Yes.
workspace root project, it needs to find the child.
No, the other way around in this case. Because I mean, you can go on the terminal into the CLI folder here and run build and all that stuff, and it knows to which workspace it belongs. So it has to find this CLI project has create has to find the workspace.
So in the CLI you can run cargo build.
Exactly. Yeah.
And
Yeah.
then
That's
it
one of
still
the
needs.
features. Yeah.
Right. Okay, now I understand it. Okay, all right. So I doubt that this is possible to use the same crate in two different working spaces.
Yeah, I mean, it will stop when the first workspace it finds. Yeah.
Thanks.
Okay. There are any more questions about the workspaces?
No,
I mean,
not from my side.
I mean, they're quite straightforward. I mean, there's really not much to them, other than the features they have, which are very useful in a large-scale project. So what else? Yeah, when you make a project like OpenEthereum has got I think 377 crates in the project, or dependencies, altogether, or crates which get built when you do a cargo build. So keeping a lot of them in a single repository when sometimes it makes sense, but often it's better to spread them a little bit out. I mean, especially if the functionality is shared between multiple projects, like it was at Parity Technologies. They put a lot in different repositories, but of course, having a separate repository for each of the crates would be a total nightmare. We would have hundreds of Git repositories that would be very, very hard to manage. So of course they have got some crates where it makes sense to have a dedicated repository for them. But in most cases, there are more than one crates in a repository, and especially in the main application repository, I think there will be I would say 40 or 50 crates in one repository. And
I think it's a trade-off, right? Because on the one hand, you don't want to have a too huge Git repository, but on the other hand, you don't want to split it up because it becomes a management nightmare. So probably it might work nicely with Git submodules or anything like that, and then checking it out recursively.
Yeah, I mean, with these Rust projects, they don't use sub repositories, or I haven't seen that so far. But of course, I mean, that's what we will cover as well. It's really flexible. Cargo is really flexible from where you can pull in the code.
Okay.
And yeah, it's a balancing act. I mean, I think you have to constantly review your code, or like once a month, or at least once half a year would be nice, to go through your structure and see which crates should reorganize, which crates should become their own repository and stuff like that. Otherwise, it will become a mess after a while. And one nice feature in Cargo is that you can nest crates. So it really there's really nothing that stops you from hierarchically organizing crates. They don't influence each other at all, as long as you follow the regular crate structure. I will show an example of these nested crates later in this talk. And of course, there's one term called crate shattering, because oversized crates are a pretty common problem in Rust, especially if they become a build performance. issue when they're becoming too big. So shattering them, splitting them up in crates, and doing that in a way that increases performance instead of decreasing the performance. It's also one big topic in the Rust community. So okay, as you said, referencing crates in cargo.toml is really flexible. One thing that probably everybody has seen is you can use crates.io. So you can define a package that's available on crates.io and which version you want of that package, and Cargo will download them automatically, which is very nice. But you can also define crate dependencies which are local to the repository or the directory. And these can even go down. These can be go up in the directory tree, down in the directory tree. Yeah, any relative path would work basically. What is important is that the name always has to match the name that is defined in the cargo.toml file of the crate. So that you can't redefine it the way you want. It has to always match. And that's also true for Git repositories. You can directly reference a Git repository. And here again, the name has to match the name of the crate you want to include. And as you see here, there is no relative path which you specify in the Git reference, and you can't add a path to it. Yeah, and that would be very inconvenient if that's if it would only look at the base folder in that case, because then you could only have a single crate in a repository. And but for that, the Cargo has got a very nice feature, and that it can find any crate in the directory tree of a Git repository. So you can define, and in this case, it's actually the example I show here. That is actually the case. So I would reference the HPPFT library, but I don't reference the HPPFT crate. I reference the HPPFT testing crate, and that's of course not in the base folder of the HPPFT repository. So Cargo will walk the directory tree of the GitHub repository until it finds a cargo.toml file that defines the name HPPFT_testing, and that it will then compile into your code. And with these three references, you can organize your code pretty much whichever way you want. You can split it out in repositories. You can have it in subdirectories in your current repository, or you can put it up on crates.io. It's very flexible in that way. Are there any questions about crates referencing?
It's really just the name of the crate. So in the relative case, the folder must not be called engine, right?
The folder can be called engine, but it doesn't need to be called engine.
Right.
But
okay.
in the cargo.toml file, it has to be called engine.
Right.
So the path itself, or the path on the disk is irrelevant, but the name of the crate that's irrelevant. That's very relevant. That's very relevant. And of course, inside your own crate, you can import that crate with whichever name you want. You can import it as a different name as well. So you've got the flexibility to name it differently within your own crate, so to reference it under a different name.
What I do not understand is why does it limit that you can import two different versions of the same library? Because they would have the same name, right? And therefore they cannot be imported at the same time.
Yeah, I mean, of course, in Rust, I think if you import something or a specific version of a crate, as far as I know, the version is somehow part of the referencing. I mean, that's
Yeah, but the issue is that you cannot import two different versions at the same time, even though this might be interesting in order to ensure compatibility in some software, for example.
Yeah, I mean, you should within your code base, you should make sure that you use the same version of the base libraries. I mean, the rand library is a good example. That's always used because that was really difficult to get to work properly. When I imported, for example, the HPPFD library, use a different version of the rand of the random crate than the Open Ethereum code base did, and that resolving that was a bit difficult.
Yeah, I also think the problem really occurs if you have dependencies, and so you probably will not use this different versions in your own code, but your dependencies might use different
exactly, yeah.
versions.
Then why is there this restriction in the first place?
Well, I mean, in my case, I actually had to update the Open Ethereum code base to allow me to use newer versions of rand. So I could compile it with the Open Ethereum code base.
Okay.
Okay. So yeah, nested crates. As I mentioned, you can organize crates whichever way you want in your directory tree, which means you can put a crate into another crate, which we show here. So you have got the regular structure that you've got a cargo toml file and then a source folder which has got the source code for that crate. And within that crate folder, you have got another folder. And since it's not referenced by cargo.toml of the parent crate, it will simply be ignored, which means it's not a problem at all to add a new folder of any name that's not used in the parent cargo.toml file, and set up another crate in there. And that way you can organize crates under a crate. I mean, sometimes.
Hello.
Hello.
Hello, Lukas.
Hi.
Somebody else coming?